Lesson 4 in Unit 6 talks about other attributes of quadrilaterals, and we're going to introduce the term symmetry. Symmetry is very easy to think about because if we fold something in half, do both sides look the same? So here we have, in this trapezoid shape right here, we have a line of symmetry because if we fold it in half or cut it in half right there, this side is a mirrored image of this side. This rectangle has two lines of symmetry. One, if we cut it down the middle or fold it down the middle vertically, the left side and right side are identical. The second one is if you go horizontally here, the top half and the bottom half are the same. A square has four lines of symmetry because we can go vertically and horizontally like we did with our rectangle. If we go vertically, the left and right are the same. Horizontally, top and bottom are the same. And if we go diagonally, we see that that part there is the same as this part here. Or if we go diagonally here, we go that there and that there are the same. So symmetry is very easy to understand. The kids aren't going to have a problem with that. Venn diagrams are a little tougher. So what they do is the Venn diagram sorts things into categories based on attributes. So when we're talking about a Venn diagram, we're talking about things like this. So it says, in this circle on the left-hand side, everything that has one or more right angle goes into this circle. On the right-hand side, everything that has two pairs of parallel sides goes in there. And this overlapping part right here would be those objects, these quadrilaterals over here, that have both one or more right angles and two pairs of parallel sides. So it's a little bit different in that regard. So let's take a look at A first. A is a square, and we're looking at one or more right angles. Does it have one or more right angles? Well, yes, it has 1, 2, 3, 4. It has 4 right angles, so we know it goes in there. But let's take a look, and does it also have two pairs of parallel sides? Well, the top line and the bottom line are parallel, and the right edge and the left edge are parallel. So it would actually go in here because it has one or more right angles and two pairs of parallel sides. Let's take a look at B. B has a right angle there and a right angle there, so it definitely would fit in here. And then does it have two pairs of parallel sides to go in here? Well, it has one pair of parallel sides because the top edge and bottom edge are parallel, but it doesn't have two pairs. So it would only go in the right side because it fits this criteria, but it does not fit this criteria. Let's look at C. For C, do we have any right angles? Well, we take a look at the shape and we say, nope, no right angles. Does it have two pairs of parallel sides? Well, the top and bottom edges are parallel, and the right and left edges are parallel, so we would put it over here. Let's look at D. Right angles? None. Parallel sides? Two pairs? Yes, it does. It has two pairs of parallel sides, so it goes over here. Can't go in the middle because it doesn't satisfy both of these criteria. What about E? So we take a look at it. It has 4 right angles, so it has more than one right angle. So it definitely goes in this side over here, but does it go in the middle? Let's take a look and see if it has two pairs of parallel sides. Yes, it does, top and bottom, and right and left. So A and E satisfy both criteria, both attributes, one more triangle or right angles, and two pairs of parallel sides. Look at F. F is a kite, and it has two pairs of adjacent sides that are equal, but there are no right angles, and it has no pairs of parallel sides. So it doesn't fit into this circle because it has no right angles, and it doesn't fit into this circle because it has no parallel sides at all. So F actually goes outside of both of them because it doesn't fit either of these attributes. So based on that, let's see if you can finish off G, H, I, and J.